Since 2019, Google celebrates every year the best hackers who hacked into Google Cloud. Yeah, Google gives out prizes for the best security issues found in their own Google Cloud products. And it's time again. The winners of the GCP Prize 2022 are in, and we can now look at the best write-ups to learn how we could have hacked into Google Cloud. This is especially interesting to me because our learning platform Hackstreet.io, specifically the lab system where you can launch challenges to practice hacking, we are running on Google Cloud as well. So I want to know if any of those security issues could have affected us. And besides that, I'm also working as a security professional and I try to find issues like those all the time. So for me, this is also a moment of reflection to ask myself, could I have found these issues myself? But I really hope I can answer this with no, because the GCP prize for the best bug is $133,337. And that is a crazy amount of money. And if I realize I could have found these issues myself, then every year I tell myself I should try to find a bug, but then I don't try. And every year since 2019, I regret that I didn't do it. So let's see this year. Will I regret not having participated? We will see. So let's start with the 7th place and work our way up. Command injection in Cloud Shell by Bagra Eskizi. This got 7th prize and got awarded an additional $13,337. Cloud Shell is a feature where you get a basic shell in your browser to access various Google Cloud things. And it also comes with this integrated IDE. And this is interesting because in 2019 there were Cloud Shell bugs winning the GCP prize. And then in 2021 there was another one, even with the same title like this one in 2022, a command injection in Google Cloud Shell. But it's also not that surprising. Looking back at the URL of the Cloud Shell back then, it's a very different one to the one today, which shows that this feature is constantly in development and changing, and changes increase the chance of new bugs. So here we see the result. Anyway, Bagra found out that the project name getParameter appears to be placed inside a Python config script, and this script is executed. See here the syntax error when using a single quote in the project name. And now it's pretty straightforward. Inject some malicious Python code, and if a victim opens this link, you get arbitrary code execution in their shell. Will I regret not having participated? We will see. Well, let's not think about it and just be happy for Bagra. Congrats. I also really like this bug because of how straightforward it is and also how easy to understand the write-up is. Overall, good job. And now let's move on. Prize number 6. $13,373 goes to OBMI. That is actually a familiar name. OBMI also won a prize in 2019. He actually got this year's prize for the write-up of 3 bugs. First one is actually a XSS in Cloud Shell. It's basically a reflected XSS with the file name of the uploaded file. See here in the screenshot the name. This is really interesting because this is similar to the reflected XSS OBMI found in 2019. Look at this. Here it was an error page, but it was also file related, file not found. Fascinating. But this is not all. To realistically trigger this XSS, you need to combine it with a CSRF, or it's just a self-XSS. And so the CSRF is actually the second issue described here. Now you can combine the CSRF and the XSS into a single exploit. Here's JavaScript code for it. First, it dynamically creates a file upload form with the XSS payload in the file path and then submits the form. Sounds simple, but there's a small detail that makes it a little bit tricky, because the host that is vulnerable to the CSRF and the XSS has a random ID, and as an attacker, you would need to know this. In OBMI's write-up of 2019, he actually described a method to leak the hostname through a redirect and triggering a CSP report rule. Pretty clever. So how did he do it this year? Well, the write-up is not mentioning it directly, but if you watch the proof of concept video, you see a weird interaction. There is a small window popping up and instructions to drag and drop the image. And I'm not 100% sure, but I think OBMI found an endpoint that redirects to the unique ID with a specific image. And when you drag and drop an image, you can write some JavaScript to capture the URL of the dropped image. So if this image is indeed hosted on the unique URL, then this drag and drop will leak the unique host ID. It's just a guess, but I'm like 70% sure that this is what's happening. So the full attack requires some user interaction, but still a cool technique. But also this was not all. There's a third issue, XSS in the Markdown viewer. This one is also pretty interesting because there was CSP to prevent JavaScript execution, but with a meta tag you could redirect the embedded frame to a target domain. And turns out the parent frame had an insecure post message handler that can be used to XSS the parent. But this is still not all, because lastly OBM showcased a cool post exploitation technique that I did not know of. Apparently there exists a NEL response header, which stands for network error logging. And when your server returns the NEL header, then any network request errors are forwarded to the specific report to domain. So that's kind of similar to how a CSP report URI works, just for network errors. And in this unique app context that is Cloud Shell, OBMI explained that you can replace the web server running on your current Cloud Shell with a server that sets this header. And if then a user loads the server, the browser then sees the NEL header and remembers that any networking errors should be reported to the attacker-controlled server. And that is kind of like a backdoor, because every time when a user starts a new dev shell session, the browser sends authorization requests to the VM origin with the OAuth token in the URL. And because the dev shell is slow and has not started yet, the server responds with a 503 HTTP error. That is a network error. So the browser will send a report to the attacker-controlled server, leaking the OAuth token. Very clever. And I didn't know about this technique. And I guess Google agreed, and so OBMI wins the 6th GCP prize. Now we come to the top 5. Here we have a white paper with the title Kubernetes Privilege Escalation, Excessive Permissions in Popular Platforms by Yuval Avrahami and Shaul Ben-Hai from Palo Alto Networks, and they won $17,311. So this is not even a typical bug report. It is a research paper covering more than just Google Cloud's Kubernetes products. This paper talks about how Kubernetes DaemonSets often run with excessive permissions, and this is common in lots of different Kubernetes setups. I'm still learning a lot about Kubernetes, and for me, actually, I learned from this what DaemonSets are. So let me now explain what I just learned to you. DaemonSets are basically just pods or containers that run on every single node, so every single machine of a Kubernetes cluster. And DaemonSets are often used for very specific machine configurations and thus often have higher privileges. So if an attacker exploits one pod, for example a web server, and manages to escape the container to the host, then the attacker can access privileged DaemonSet containers and then use those privileged ones as what they call a DaemonSet trampoline to then compromise the complete cluster. And here GKE, Google Kubernetes Engine, when using Dataplane v2, they were also using excessive permissions. And this was reported, Google fixed it and even gave them $13,000 bounty for this. Also, besides this paper, they released a tool you can use to check the permissions in your cluster. So while this white paper does not directly describe a typical bug or security issue, it's really defense in depth. Overall, this research contributed to more resilient Kubernetes setups in general. Also, Yuval presented their research on trampoline pods at KubeCon. If you're interested in more details, I will link the talk below as well. So you can see, this research really helps not only Google, but the whole Kubernetes ecosystem can learn from it. And I guess because of that, Google wanted to reward this with the 5th GCP prize. Next, we have something special.
Triple kill!
The bug hunters Sivanesh Ashok and Sriram KL teamed up and won 4th, 3rd, and 2nd prize. $31,311 for client-side SSRF to Google Cloud Project Takeover, another $31,337 for bypassing authorization in Cloud Workstation, and then $73,331 for SSH key injection on Google Compute Engine. Damn, what a bloodbath. And so let's see what they found. The SSRF to Google Cloud Project Takeover is pretty straightforward. They found an endpoint called proxy which contained the domain, and the response looked like it contained authenticated data. This definitely screams SSRF. So they tried to set their attacker domain, but that didn't work. There was a check. However, the check appears to be implemented with something like URL contains computegoogleapis.com, because attacker.com/computegoogleapis.com actually worked. And so when tricking a victim to visit this URL, then Google Cloud would send a request to the attacker domain with the Google Compute credentials of the user, which can then be used to basically take over the Google Cloud project. Pretty cool. Also, the write-up discusses a bypass they found after the first fix to properly restrict the domain to google.com, because they managed to find an open redirect on feedproxy.google.com. So overall, a pretty cool write-up. But let's move on to the next one, bypassing authorization in cloud workstations. And this one turns out to be basically an OAuth vulnerability. Cloud workstations are kind of similar to the Cloud Shell we have seen before, but it's intended as an actual workstation. And as they write here, using a non-google.com subdomain means the workstation cannot access a user's google.com cookies, so it should use another means of authorization. So they looked into the OAuth authentication flow and noticed that the redirect parameter contained a state object, and the state object contained the actual redirect target host. So by setting the target host to their own domain, they can then craft an OAuth link that then, when visited by a victim, causes the workstation JWT, the authentication token, to be sent to the attacker host. Cool. Kinda typical OAuth vulnerability, abusing the redirect and not properly implementing the state parameter. And you would kinda think Google knows how to implement OAuth by now. But this is a typical flaw of mine. I often assume they should know this, so it's not worth my time to check it. And I would probably have not found this issue because of that. And yet, this example shows it can still happen. You can never be 100% sure without actually checking. And I guess this OAuth issue was a surprise to Google as well, because they rewarded this write-up with the third GCP prize. And now let's come to the last issue of the three, the one that got them the second GCP prize. This gave them an additional $73,331. SSH key injection on GCE. This issue affected the SSH in-browser feature of Google Compute Engine. This feature looks similar to the Cloud Shell that we have seen before, but this specifically is a SSH shell into an actual running Compute Engine instance that you rented. And here the hunters noticed a feature where you can enter the username and it will then use this user for the shell. So I think the expected usage here is that on this machine there exist different users and you can choose which user you want to use for login. But that's not only what it does, as hunters have figured out. So first they noticed that this endpoint was vulnerable to CSRF. Just make a victim visit a URL with the get parameter, new Linux username, and surprisingly, the Linux username will be added if it didn't exist before. Kinda annoying, maybe disruptive, but not really a serious security issue. But then they also noticed, after playing with the different special characters in the username, that for each new username, a SSH key is added. And look at what happened when they tried a command injection payload with curl. The command injection didn't work, but the key format is completely messed up. And it looks like they can control both the username and the key part, which means they can craft a special injection payload to inject their own SSH key into the authorized key file. You can see this here in the proof of concept video. Open that crafted URL, wait a moment, and they can SSH into the server. Will I regret not having participated? We will see. Yeah, I guess. Anyway, I was wondering why this functionality exists. I mean, a feature to select which user to log in is fine, but why write an SSH key to the authorized key file? And Google told me that the reason is simple. The JavaScript frontend code actually generates a random SSH key that is then submitted to the machine via a backend API, so that the browser SSH client can log in with that key. Also, this feature is useful to fix your machine in case you accidentally delete your user's home folder. In such a case, the authorized key file would be missing and you couldn't log in via SSH anymore. So this functionality would also write a new SSH key, so you can still use this browser SSH feature to log in. So this feature is useful, but unfortunately it was not implemented properly and it was vulnerable to this SSH key injection. Nice. And now the moment we have all been waiting for, Who won the GCP Prize 2022? What was the best security bug in Google Cloud? Drumroll. Privilege escalation in GKE Autopilot, so Google Kubernetes Engine, by Yuval Avrahimi. In June 2021, Unit 42 researchers from Palo Alto Networks disclosed several vulnerabilities and attack techniques in GKE Autopilot to Google. Sounds scary, and we at Hextree also use GKE Autopilot. But there's one strong requirement for this to work. The attacker needs to be able to create pods, so maybe a compromised developer account or so. But if that is the case, then the attacker could even abuse these issues to escape their pod and compromise the underlying node, escalate privileges and become full cluster administrator, and covertly persist administration access through backdoors that are completely invisible to cluster operators. And in case you didn't notice, we know Yuval from Palo Alto Networks already because they got the 5th prize this year for their white paper on excessive DaemonSet permissions. And remember, that white paper described the situation where you already have a pod escape taking over the node and then you could abuse the privileged DaemonSets. Well, this write-up now of the first prize explains how a user that can create pods can escape to the node, and they could make use of the DaemonSet research. That's kind of a cool follow-up connected story. Anyway, let's have a closer look at their findings. They found issues in Google Kubernetes Engine Autopilot, and we already know the attacker in this case needs to be able to create pods. But if that is given, how does the pod escape work? Well, standard pods usually don't need special privileges, so Google prevents you from running high privileged pods. However, there are a few use cases where you maybe need to give a pod special privileges, and for that purpose, Google has an allow list that restricts what is allowed to run with specific higher privileges. They looked at this allow list and they found this Datadog image that has an exception allowing mounting different host paths. Most interesting is of course the containerd socket file that's like Docker socket, and basically it can be used to run any privileged containers you want. But just running this image does not necessarily help you because you don't actually want to run this image as intended. So how can you execute arbitrary code so that you can access containerd? Turns out you can specify an alternative command to execute, and they simply execute bash. So they now get a shell in this privileged container. They can access the containerd socket, which can be used to create another container with full host system access, achieving a pod escape, compromising the complete node. Cool, but this is not all. They then went further to assess the impact of the node compromise. What can they actually do with it? And eventually they also managed to escalate privileges to a complete cluster takeover. And in this process they also developed a tool called SA Hunter, which they use to assess excessive permissions, which is the predecessor of RBAC Police, which is the tool they mentioned in the other white paper. But the privilege escalation was not all they did. They even figured out a very interesting way to backdoor the cluster. If you're interested in that, make sure to read the original write-up. So overall, they documented lots of different things, and in the end also looked at the bigger picture beyond Google Kubernetes setup, preventing similar attacks on Kubernetes environments. And so this is probably the main reason why they won this year's GCP prize. This write-up is not about a especially critical bad vulnerability. The requirements here are that you already have permissions to create pods, so that shouldn't affect many customers using Google Kubernetes Engine. But the researcher really dug deep into the topic and highlighted lots of other small weaknesses in Google's setup. This research led to several hardening improvements in Autopilot that make it a better secure by default Kubernetes offering. So it obviously helped Google, but it also benefited lots of other Kubernetes environments. Also, here's a write-up from Google on their security blog, Privileged Pod Escalation in Kubernetes and GKE, basically discussing the results of the research by Yuval. So this is the 5th prize and also the first prize. And I think the fact that Google even wrote this blog post about their changes shows the impact that this winner's report had for Google Cloud. So congratulations Yuval for winning, excellent work. So what did I learn from all the GCP Prize Winners 2022? Will I regret not having participated? We will see. Yeah, I guess again I regret not having participated. Oh. Most of these issues, especially the Python code injection and the SSH key injection, they were pretty straightforward. Also, the OAuth issue is kinda a typical OAuth issue. Same with OBMI's CSRF and XSS issue. They were also pretty clear. But the Markdown XSS was interesting because it exploited a post message handler, and that is something I could miss. Same with the authenticated SSRF, I can see me missing that one too. But the other write-ups were super clear, and in principle they weren't difficult issues either. So all in all, these are not crazy difficult bugs. They are all pretty standard web security issues, which I think many of you could have found. The real challenge, I think, is the large number of potential features. Lots of attack surface that might take some time. But time issues can be solved with just spending more time, and the bugs themselves were not that difficult. So in summary, yes, I could have found these issues too. Damn. But I'm happy to say that at least the first prize is about a topic I would have not been able to do. I hate Kubernetes too much to spend this much time on it. So kudos. I don't know how you do it. I don't have this level of patience for Kubernetes. Alright, there we have it. Congratulations to all the winners. Well deserved. And if you are interested to learn more details about the issues, you can find the link to the official blog article with the winner announcements below in the description. Also, if you are looking for updates on Google's vulnerability reward program, follow Google VRP on Twitter. Thanks again, Google, for sponsoring this video, and thanks for being so open about your security issues. I'm not saying this because they sponsor me, or I guess maybe yes, because they sponsor me, because I truly think they handle security in such an interesting and forward-looking way. I said it multiple times before, it's kind of mind-blowing that they pay money that I expose, security issues that Google had this publicly on YouTube.